Okay, so we'll start with problem number 1, and that is, given the quadratic function f of x equal to x squared minus 2x minus 3, and we're going to perform the following. So here, this will be laid out for you. You have to determine whether the graph opens upward or downward, and then number 2, part B, identify the vertex of the parabola, then part C, find the x-intercepts, find the y-intercepts, and then sketch the graph using the intercepts, vertex, and additional points. Okay. Also, you will have graph paper to do the graph. Okay. So I guess I'll go ahead and give this a heading. And in problem number 1, you got f of x is equal to x squared minus 2x minus 3. So in this case, in part A, we're going to determine whether the graph opens upward or downward. So the A will determine whether the parabola opens upward or downward. If it's positive, it opens upward, or if it's negative, it opens downward. So in this case here, what's the A in this case? That's the coefficient of your x squared term. Positive 1. And of course it is positive, so that means that the parabola will do what? Open upward. So that's all you have to mention right there. What A is and whether it opens upward or downward. Now part B is identifying the vertex of this parabola. And I might as well go ahead and add this as well. Add the axis of symmetry. So there are two things that you can identify, the vertex and the axis of symmetry. All right, in this case here, we know what A is, that's 1. What would B have to be? Negative 2. That's the coefficient of x. So to find the x-coordinate of that vertex, it'll be x equal negative b divided by 2a. X equal negative b divided by 2a. So the b is negative 2, so it'll be negative of negative 2 divided by 2 times a, which is 1. And negative of negative 2 is 2. 2 times 1 is 2. 2 divided by 2 will be 1. So the x-coordinate of that vertex is going to be 1. Now for the y-coordinate of the vertex, we have to take the x, which is 1, substitute it for each x in the f of x function. So it'll be f of 1. That'd be equal to 1 squared minus 2 times x, which is 1, minus 3. So here 1 squared will be 1, minus 2 times 1, which is 2. So what's 1 minus 2 minus 3? Negative 4. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So the ordered pair, 1, negative 4, is the vertex. Excuse me. Now the axis of symmetry, of course, that's the x-coordinate of your vertex. So my axis of symmetry is x equals 1. When you identify your axis of symmetry, it is a vertical line. You must say x equals to whatever that x-coordinate of the vertex is. Otherwise, you'll lose points on that part of that problem. Okay, so that's part B. Part C is finding the x-intercepts. Anytime you're finding the x-intercepts, you always let f of x equal 0. F of x will be equal to 0. And then solve for x. So f of x is at x squared minus 2x minus 3 equal to 0. Now, pretty much, the only thing we can do here is do some factoring here. And I'm going to have to factor x squared minus 2x minus 3 into two binomials here. So x squared breaks up as x and x. Now, what factors of a minus 3 will give me minus 2x as a middle term? 1 and 3. And the 3 has to be minus because the middle term is a minus. Keep in mind the larger of the two factors will take the sign of the middle term. So this will be x minus 3 times x plus 1 equal to 0. And then we set each binomial factor equal to 0. So this means x minus 3 is equal to 0, and x plus 1 is equal to 0. And then for each equation we solve for x. So for the x minus 3 equals 0, that would be x is equal to 3. And then for the x plus 1 equals 0, x is equal to negative 1. So here we got two x-intercepts here. One of them will be, in this case, 3, 0, and the other one, negative 1, 0. Because those are the 2 points where this graph will be crossing the x-axis. Okay, so that's part C. All right, part D is this, finding the y-intercept. Now, of course, to find the y-intercept, we evaluate f of 0. That means we substitute each x with 0 and simplify. So this means we're going to have 0 squared minus 2 times x, which is 0, minus 3. All right, so when we simplify this, 0 squared is 0, minus 2 times 0 is 0, minus 3. And this ends up being what? Negative 3. So the ordered pair for a y-intercept would be 0, negative 3. Okay. And then part E is just simply taking all of this information and graphing it on a coordinate plane. Okay, so let me, I know this is going to be hard for me to do here, but I'm going to put part E up here. Do the graph. Maybe if I zoom out. Okay. All right, so first of all, let's plot the vertex, which is 1, negative 4. So I'm going to go to the right 1 and down 4. I'm also going to draw in that axis of symmetry, which is the vertical line, x is equal to 1. So here's the axis of symmetry. It always goes through the vertex and crosses the x-axis at that x value. Because that's what's going to make the left side of the graph of the parabola the mirror image of the right side of the graph of that parabola. All right, let's see here. Next, my x-intercepts are 3, 0, and negative 1, 0. So 3, 0 will be to the right 3 on the x-axis. Negative 1, 0 will be to the left 1 and on the x-axis. My y-intercept is 0, negative 3. So On the y-axis, I will go down to -3 and draw that point. And I will draw another point that is symmetric with this y-intercept and the axis of symmetry. Well, the distance from the y-intercept to the axis of symmetry is one place to the left. So the other point has to be one place to the right, which would be here, containing the same y-coordinate. So this should be enough points for me to draw the graph of this parabola. All right, so this is the graph of the parabola f of x equal to x squared minus 2x minus 3. Okay. Are there any questions about problem number 1? All right, problem number 2 is to do this, and I'm going to zoom in a bit. Given the function f of x is equal to negative 4x squared plus 160x minus 600, here you're to perform the following. And in part A, you're to determine without graphing whether the function has a minimum value or a maximum value, and then find the minimum or maximum value and determine where it occurs, and then identify the function's domain and range. Okay, so problem number 2, here we got f of x is equal to negative 4x squared plus 160x minus 600. All right, so in part A, here's what we got. Here we identify what A is to determine whether we have a minimum value or a maximum value. And keep in mind, if A is negative, we have a maximum value, or if it's positive, we have a minimum value. So what's your A in this case? Negative 4. And based on that, do we have a maximum value or a minimum value? Maximum. So we know we're going to have a maximum value for this function. Now, part B is to find out what that maximum value is and where it occurs. So I know what A is, that's negative 4. What's B? 160. And of course, we always use, in this case, negative B over 2A. And our B in this case is 160. So let me bring the negative over, replace the B with 160, divided by 2 times A, which is negative 4. And I'm going to bring that negative 160 over. 2 times negative 4 is negative 8. And what's negative 160 divided by negative 8? Just 20. Negative divided by negative, that's positive. Okay. So we know that the maximum value occurs at x equals 20. But let's find that maximum value itself. And we do that by substituting every x in that function with 20. So f of 20 would be this. Negative 4 times 20, and that's squared, plus 160 times x, which is 20, minus 600. Now, I think you can type this all in the calculator if you want to, or just see negative 4 and then 20, and then we square it, plus 160 times 20, and then minus 600. And that should give you 1,000. Or if you want to work it out the long way, 20 squared is 400. 400 times negative 4 would be negative 1,600. Plus 160 times 20, 3,200 minus 600. And that will give you 1,000. So the maximum value is 1,000, and it occurs when x is equal to 20. Are there any questions about part B? Now, part C is to identify the functions, domain, and range. Now, the domain should be quite easy because what type of function is f of x? Is it polynomial, rational, or radical? It's a polynomial function. And in a polynomial function, there are no restrictions on our x's. So that means the domain will have to be an in-interval notation, all real numbers. And in interval notation will be negative infinity to infinity. Now for the range. In this case, the range is going to be set of all y values. And we have a maximum value of 1,000, meaning that would be the highest y value it would ever be for that quadratic function. So that range will be from negative infinity up to 1,000. And here we're going to use the bracket for the 1,000 because that value is included. And you have to kind of picture the graph of that function is opening downward, so that means we have a maximum value. The highest will be 1,000. That means anything less than 1,000 would work for that function, at least for the range. All right, are there any questions about problem number 2? Okay. All right, number 3 is using the leading coefficient test to determine the end behavior of each polynomial function. So in part A, here we got f of x is equal to x to the 5th plus 17x cubed minus 11. And I want to determine the end behavior of that polynomial function. You have to identify two things, n and a sub n. The n, of course, is the highest exponent in that polynomial function. The n is a sub n is the leading coefficient, which is the coefficient of the variable to the highest power. So what's n going to be here? 5. And a sub n would be 1. Now, for the n, we have to determine whether it's even or odd. And then a sub n, we have to determine if it's positive or negative. That will help us determine the end behavior. Is n even or odd? Odd. A sub n, is that positive or negative? Positive. So now that's going to help us determine the end behavior. And this is back in section 3.2. Oops, not f of x equal. If you have an odd degree, and it's positive, the end behavior will be this, that f of x falls to the left and rises to the right. And I would suggest that you refer to that leading coefficient test in the notes that I gave you for section 3.2. All right, now part B, we got f of x, and that's equal to negative x to the 6 plus 7x cubed plus 2x squared minus 8x minus 12. And here I want the end behavior of the graph of this function. So now we need to identify the n and the a sub n in this case. What would be the n for that function? 6. And what's your a sub n? Negative 1. Now for the n, is that positive or even or odd? Even. And what about a sub n, positive or negative? This time it's negative. Well, if it's even, that means the behavior on the left side and on the right side are going to be the same. Here it tells me it's negative for a sub n, so that means the behavior will be, they're going to be falling on both sides of the graph. So that means here the end behavior will be f of x falls to the left and to the right. Okay. So the function falls to the left and to the right. Or the graph of the function falls to the left and to the right. Any questions about problem number 3? All right, number 4 is finding the zeros of the polynomial function f of x is equal to 3 times the quantity x minus 2 squared times x plus 5 quantity cubed, and give the multiplicity for each zero. And then state whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. So in this case, number 4, I'll go ahead and write down the function. And then, to find the zeros, we always set the function equal to 0. And my f of x is at 3 times the quantity x minus 2, and that's squared, times x plus 5, and that's cubed, equal to 0. And then we go ahead and just, well, since it's already factored completely, we can set each factor equal to 0. So that means I can set 3 equal to 0, and then set x minus 2 quantity squared equal to 0, and set x plus 5 quantity cubed equal to 0. Well, 3 equals 0 is a false statement, so we can eliminate that. But for the x minus 2 quantity squared equal to 0, what would be the opposite of squaring something? Square root. So we'll take the square root on both sides. So that means x minus 2 is equal to 0, and what must x have to be equal to? 2. So one of my zeros is x is equal to 2. And then for the x plus 5 quantity cube equal to 0, the opposite of cubing something would be to take the cube root on both sides. So that means that x plus 5 equals 0. And what must x have to be equal to here? Negative 5. So these are my zeros for this polynomial function, x equals 2 and x equals negative 5. And from that, we're going to state their multiplicities. So let's start with the x equals 2. All right, so the x equals 2 came from this x minus 2 up here. The exponent for the x minus 2 is 2. So x equals 2 has a multiplicity of 2. And for the x equal negative 5, that came from this x plus 5. The exponent for that was 3. So x equals negative 5 has a multiplicity of 3. Now we need to determine what's happening at each of those zeros here. Like for x equals 2, it has a multiplicity of 2. Is that multiplicity even or odd? It's even. So with an even multiplicity, that tells me that the graph of this function is going to touch the x-axis at 2 and turns around. So it'll touch the x-axis and turns around at x equals 2. Now for x equals negative 5, it has a multiplicity of 3. Is that even or odd? This time it's odd. So with odd multiplicity, the graph of that function crosses the x-axis. So we can just say here that this function f of x crosses the x-axis. Okay. All right. Are there any questions about problem number 4? Finding the zeros and then stating their multiplicities and then determining the behavior at each of those zeros there. Okay, now problem number 5 is graphing a rational function using that 7-step procedure that I gave you in the handout for section 3.5. And here we got f of x equal to 4x squared divided by x squared minus 9. Okay, so let me bring up a sheet that has the coordinate grid on it. All right, so in problem number 5, this is the rational function f of x is equal to 4x squared divided by x squared minus 9. All right, and there are 7 steps to doing this. All right, the first step is to determine whether or not it has symmetry. And to determine whether it has symmetry and the type of symmetry that we have for this, we just substitute every x with negative x and simplify. So that means I'm going to have 4 times, and x will be replaced with negative x, and that's squared, divided by negative x, again, substituted, and that's squared, minus 9. And when you square a negative, it's going to be positive. So negative x you squared that would be positive. So it'd be 4x squared in the numerator, and the same thing here. X squared minus 9. So compare that with the original function. Is that the same? Yes, it is. We got the original function that we started off with. So that means this graph will be symmetric with respect to the y-axis. So with these, we're going to be dealing with either y-axis symmetry or origin symmetry or no symmetry. Origin symmetry is when you get the opposite of the original function after substituting the x with negative x. All right, step number 2 is finding the y-intercept. So when you find the y-intercept, you just substitute 0 in for x and simplify. So f of 0 would be this, 4 times 0 squared divided by x replaced with 0, and that's squared minus 9. All right, 0 squared is 0 times 4 is 0. What's 0 squared minus 9? Minus 9, or negative 9. 0 divided by negative 9 is 0. So my ordered pair 0, 0 is the y-intercept. Okay. So that's step number 2. Step number 3 is finding the x-intercepts. So anytime you find the x-intercept of this rational function, you have to take your numerator, which is the 4x squared, set that equal to 0, and solve for x. So I'm going to take 4x squared, set that equal to 0. So here, if I divide both sides by 4, x squared is equal to 0. And what number squared gives you 0? Has to be 0. Or you can take the square root on both sides. You'll find out that x does give you 0. So my x-intercept is also 0, 0. Okay. So that's step number 3. Now for step number 4 is finding the vertical asymptote, or asymptotes. Those are the vertical dotted lines that go through the x-axis. So we take our denominator of x squared minus 9 and set that equal to 0. And I'll tell you right now, there are no common factors to divide out, because usually when you're trying to find a vertical asymptote, you have to see if you can factor the numerator and then factor the denominator and try to divide out any common factors if you can. So like 4x squared is already simplified. How can we factor x squared minus 9? X plus 3 times x minus 3. Can we divide out any common factors? No. So we can take, and in fact we can take that x plus 3 times x minus 3. So I can leave that up here, because that x squared minus 9 does factor as x plus 3 times x minus 3 equal to 0. And then we can solve, set each factor equal to 0 and solve for x. So this means x plus 3 equals 0, x minus 3 equals 0. So for the x plus 3 equal to 0, then it'd be negative 3. And what about for x minus 3 equals 0? Positive 3. So these are my two vertical asymptotes. One will be at x equals negative 3, and the other one is at x equals positive 3. Okay, so that's step number 4. Okay, step number 5 is the horizontal asymptote. That's where we identify the n and the m to see if it's greater than, less than, or equal to m. Well, for the n, the highest exponent in the numerator is what? 2. Your m is the highest exponent in the denominator. That's what? 2. Compare n and m. Is n greater than, equal to, or less than m? If they're equal to. So that means to find out what our horizontal asymptote is, we have to look at our leading coefficients. A sub n divided by b sub m. All right, based on this, my leading coefficient in the numerator is what? 4. And what's the leading coefficient in the denominator? 1. So I have 4 divided by 1, which is 4. So the equation y is equal to 4 is my horizontal asymptote. Okay. That's step number 5. Now step number 6, and I had to do this underneath this coordinate grid, is going to be the table of values. So pretty much we're going to be using our graphing calculator, which is going to be important that you do bring your own calculator to class with you. And then number 7 is just a graph. And what I'm going to do is graph what I've already have here. I've already got my y-intercept and x-intercept, which is 0, 0. So that's the origin. And then my vertical asymptotes, there are 2 of them, at x equals -3 and x equals 3. So I'll go ahead and graph that as well. And then my other will be at x equals +3. That's my other vertical asymptote. The horizontal asymptote was y is equal to 4. So I'll go up to here for y equals 4. It's a horizontal line going through the y-axis at 4. All right, so I know I'm going to need some additional points here to come up with the graph of this rational function. Now, I'm going to pick points to the left and to the right of each vertical asymptote and the x-intercept. So my first vertical asymptote was at x equals -3. Let's pick values like -6, -5, and -4. And then to the right of -3, let's use -2 and -1. And I've already got 0, 0. That's my x and y intercept. To the right of that, let's use x equals 1 and 2. And the other vertical asymptote is at x equals +3. Let's use 4, 5, and 6 as x values. Okay. Now we're going to enter this in the graphing calculator. And while I'm at it, let me go ahead and give you the keystrokes here. Because the numerator and the denominator are going to need to be in parentheses here. So these are the keystrokes here. For 4x squared, which is my numerator, I'm going to do left parentheses. Type in the number 4. Press the xt theta n button for the x. And then x squared to square it. And then close parentheses. Then that's going to be divided by. Now the denominator would need to be in parentheses as well, so it would be left parentheses. And then for the x, I have to press xt theta n for the x. And then x squared to square it, then press the minus key, press the number 9, and then close the parentheses. Then I'm going to do second graph for the table. So second graph, that's just for the table. So here I'm going to first go to y equal 2. Then I'm going to clear this equation out and make sure your plots 1, 2, and 3 are off. And then left parentheses, 4 xt theta n for the x, and then square it. Close parentheses, divided by, and then the denominator will be left parentheses, get the x and then square it, minus 9, close parentheses. And then for the table, we'll do second and graph. And don't worry about those decimal values. We can use those. And here I'm going to use my up arrow key to go up to where negative 6 is. So for negative 6, I'm going to have, to one decimal place, it'll be 5.3. Then for negative 5, it'll be 6.3. Then negative 4 would be 9.1. And at negative 3, that's one of your vertical asymptotes. That's why you see the word error. Then for negative 2 would be negative 3.2. For negative 1, that's negative 0.5. 0, 0 is your x and your y intercepts. So I'm going to use my down arrow key to go down to 1. Negative 0.5 for that. And notice that at negative 1 and positive 1, you get the same value for f of x. That means this graph is symmetric with respect to the y-axis. At 2, negative 3.2. X equals 3, that's the other vertical asymptote. And then for 4 will be 9.1. For 5, 6.3. And for 6, approximately 5.3. So these are my ordered pairs for the graph of this rational function. So now we're going to take all of that and plot those on the coordinate plane. Okay, for negative 6 and 5.3, sometimes it helps to zoom out. Probably not. All right, for negative 6 and 5.3 will be to the left 6 and up 1, 2, 3, 4, 5 and about a third of the way, which will be up here. Negative 5 and 6.3. Negative 5 and 6.3, about right here. And negative 4 and 9.1 will be way up here. So in this case here, I can see what one part of the graph will do. As we get closer and closer to negative 3, this graph will be rising upward and getting closer and closer to that vertical asymptote, but it will not touch it. And as we go further to the left, this gets closer and closer to the horizontal asymptote, but it will never cross it. Now, for this part in the middle, negative 2 and negative 3.2 will be to the left 2 and down 1, 2, 3, and 2/10 about right here. And then for negative 1 and negative 0.5 or negative 1/2 to the left 1 and halfway down. And then for 1 and negative 0.5, it's going to be the same thing. You can see that it's going to be symmetric with respect to the y-axis. And then 2 and negative 3.2. That should be the same y coordinate there. So on the left side, to the left of 0, it's going to be going down, approaching that first vertical asymptote, but it'll never cross it. And then to the right of 1, it's going to come down as well, approaching the second vertical asymptote, but it'll never cross it. And then these last 3 points here will be symmetric to this part right here. 4 and 9.1. To the right, 4 and up 9, and about 1/10 of the way. That's way up here. And then 5 and 6.3 will be to the right, 5 and up 6, and about 3/10 of the way, about right here. And then 6 and 5.3, about right here. So if I go to the left here, it's approaching that vertical asymptote of x equals 3, but it will never cross it. And if I go further to the right, it approaches the horizontal asymptote like this. So all of this represents the graph of the function f of x is equal to 4x squared divided by x squared minus 9. Are there any questions about problem number 5? Okay. Okay, now problem number 6. Here we're going to be using our calculator to approximate each number to 3 decimal places. Okay, and in this case here we got part A, which is 3 to the 2.4, and part B is e to the 3.4. And of course, when we type this into the calculator, we'll start with part A. We do this. We type in the number 3 and then press the hat key, which is right below the clear key. Enter, type in the 2.4, press enter. So here I'm just writing out just the keystrokes here. 3 and then the hat key, 2.4. Hit enter. And to 3 decimal places, what would this value be? 13.967. Okay, so that's the approximate value of 3 to the 2.4. 13.964. And then for part B, we got e to the 3.4. All right, to type this in, you have to press your second key and then LN, because right above the LN key is e to the x. And then 3.4, and then press enter. So second LN for the E, and then type in 3.4. And from here, you can just go ahead and press enter. And what would this value be to 3 decimal places? 29.964. Okay. Are there any questions about problem number 6? All right, number 7 deals with compound interest. In this case, we're finding the accumulated value of an investment of $10,000 for 5 years at an annual interest rate of 8% if the money is part A compounded quarterly and part B compounded continuously. All right, so we're going to identify what we already have here. We have the principal, or the amount of the investment, that's $10,000, for 5 years. That's your time. T is 5. And the annual interest rate is 8%. Now, what's 8% as a decimal? 0.08. And if you didn't know that, you can take that 8%, divide that by 100, you'll get the decimal value of 8%. I mean 0.08. Okay. Now, in part A, we're dealing with quarterly compounding. Now, if it's compounded quarterly, how many compoundings are there in a year? What's our n? 4. So here n will be equal to 4. And we have n number of compounding, so we have to use that very first formula that I gave you for compound interest. A is equal to P times the quantity 1 plus R divided by N. That quantity is to the N times T. So here we just do substitution here to find out what the accumulated value is. So A is going to be equal to P is 10,000 times 1 plus R, that's 0.08, divided by N, which is 4. That quantity will be raised to the N, which is 4, times T, which is 5. And then we just simply, well, we can type all this in the calculator and just get our answer from there. So here we got 10,000. And then left parentheses, 1 plus 0.08 divided by 4, close parentheses, and then press the hat key, then 4 times 5, and then hit enter. Now, what would this amount be to 2 decimal places? And, okay, 47 cents. So that would be the accumulated value of a $10,000 investment for 5 years at an annual interest rate of 8% compounded quarterly, $14,859.47. Okay, questions on part A. Part B, let's say that the money was compounded continuously. Let's say that money was compounded continuously. Well, if it's for continuous compounding, we use the other formula. A is equal to P times e to the RT. So here our A is going to be 10,000 multiplied by e to the R, that's still 0.08, times T, which is 5. This we can also type in our calculator to get the answer. So it'll be 10,000. Now for the E, you have to press second LN for the E. And then 0.08 times 5. So what would this value be to 2 decimal places? $14,918 and how many cents? 25. So that would be the accumulated value of a $10,000 investment for 5 years at 8% compounded continuously. $14,918.25. Any questions about problem number 7? Okay. Now, make sure you know what N is for each one of those compounding. So if it's semi-annual compounding, that means N is equal to 2. If it's quarterly, n is equal to 4. Monthly, n is equal to 12. Daily, n is 365. Because I might put something like that on the exam. All right, problem number 8. Write the equation log to the base 6 of 216 equals y in its equivalent exponential form. Log to the base 6 of 216 equals y. And we want to write that in its equivalent exponential form. Well, we start with the subscript for the log, which is your 6. That's going to be the base. What's after the equal sign becomes your exponent for the y, because logarithms means we're finding the exponent. So it'd be 6 to what power? The y. And then that's equal to what we're taking the log of, which is 216. That would be the equivalent exponential form for log to the base 6 of 216 equaling to y. 6 to the y equals 216. All right, questions on number 8. All right, in problem number 9, we got 7 raised to the y is equal to 200. Now, in that problem, you are asked to write that in its equivalent logarithmic form, 7 to the y equal 200. Well, we know we need to have log in this problem because logarithmic form has log in it. And what's our base here? The 7. So it'd be log to the base 7 of what? 200. Oops. Log to the base 7 of 200. And that's equal to what? The y. Because logarithms always equal the exponent. So 7 to the y equaling to 200 in its equivalent logarithmic form will be log to the base 7 of 200 equals y. And number 10, log to the base 2 of 64 is equal to what? That you have to evaluate without the use of a calculator. Well, you're probably going to use it anyway, so because they want you to try to use it without the use of a calculator. So the way we're going to set that problem up is this. Set this equal to, let's say, y. And then write it in its equivalent exponential form. So what's log to the base 2 of 64 equaling to y in its equivalent exponential form? 2 to the y equals 64. Now we need to write 64 as a base with a power of 2. That's 2 to what power? 6. You could do this off to the side. 2 goes into 64 32 times. 2 goes into 32 16. 2 goes into 16 8. 2 goes into 8 4. 2 goes into 4 2. 2 goes into itself 1 times. You'll see you have 6 factors of 2. So that means 64 is 2 to the 6. Well, if these bases are the same, I can set this exponent to be equal to that exponent. So y will have to be equal to what? 6. That's the missing exponent for log to the base 2 of 64. So log to the base 2 of 64 equals 6. All right. Are there any questions about problem number 10? All right, here we're going to evaluate or simplify each expression without the use of a calculator. Those are the ones that you're going to be using the inverse properties for common logarithms and for natural logarithms. Like in, let's say number 11, we got log to the base, log of 10 to the 7. Okay. So log of 10 to whatever my exponent is, that exponent. So what's log of 10 to the 7? 7. And I'm just writing down what the rule here is down here. Log of 10 to this exponent is that exponent. You don't need to write that down on your exam. Number 12, ln of e to the 9. Well, there's a property that says ln of e to whatever my exponent is that exponent. So what's ln of e to the 9? 9. Okay. And finally, number 13, e to the natural log of 7x cubed. So e to the ln of whatever is whatever. Since e and ln are inverses of each other, so what's e to the ln of 7x cubed equal to? 7x cubed. Okay. Any questions about problems 10, 11, and 12 dealing with those inverse properties of logarithms? Or does anybody have any questions about what will be on your exam, number 3, on Thursday?